Hi there folks, so let's jump right in. What we will do today is to look at a component that somebody wrote, in this case it's me, and this component has what I call junior level code in React, and we will refactor this to get it all the way to senior level, and along the way we'll see how a senior thinks and what are the guiding principles a senior developer would use to kind of solve this problem so you can incorporate this in your code. Let's get going. Let's first overlook what we are building. So basically what we're building, it's a drop-down component. It has some options and a selected value. The options get fetched over the network. So basically we get those options using a function that mimics a network behavior, and then we basically render them, and we render an option for each one of them. So this is a basic select element, and whenever the user clicks on it, we actually update this state, which is the selected value. Let's see how this looks like. Let me run this. If I'm not running it already, I might have an open tab. Perfect, it's already running, and basically this is how it looks like. Right now the component's loading, and I think yes, perfect. And these are the options that came through. Whenever I select one of those, it gets selected. That's pretty much it. Now this is a junior level implementation. It does satisfy most of our functional requirements, but not all of them, and we will start there. So always keep this in mind whenever you don't know how to start in interviews or so on. We always start with the functional requirements, which is basically, hey, what do I need in order for this to work? What does the user needs to interact with? So functional requirements. Now on the surface, it looks like this drop down satisfies all of those, but in reality there is a big flaw here, which is whenever we synchronize state with the backend, or as civilians like to call it, fetching data, whenever we get something from the backend, like in this case we get the options, we have two extra states that are not the data, and those states, as you're probably thinking, are loading and error, and this is always the same. So keep this in mind. If you fetch data, you need the loading and error state. Most libraries these days, like React query, give you this by default. In this case, it's not there. So let's add the loading and error state, right? So first of all, we're going to have a very simple one, which is a boolean. Whenever you name a boolean, we use is or has as a prefix. So it's loading, and they said it's loading. I'm not using Copilot, by the way. This is a human writing code. Try to write code without Copilot when you're not, when you don't have too many deadlines, so you're actually practicing. So we're going to use your state, and we're going to issue that as false. The initial condition of loading, it's false. So now let's see what are our state transitions. So we want to start this loading when we start fetching. So I'm going to say here, you know what, I'm going to set its loading to true because we are loading something, and whenever we finished, we're going to set its loading to false. Pretty self-explanatory. Now, although we do update the state when we fetch and we finish fetching, we're not using it. So let's go ahead and also use it as a functional requirement. As a user, we probably don't want the users to interact with the select when things are being loaded. So I'm just going to say, you know what, we're going to have disabled, right? This is a native HTML attribute, and if it's loading, then let it be disabled. The other thing is we might want to display the value of this as, hey, we are actually loading. So what we can do is to say, you know what, if it's not loading, so only render the options if you're loading. So if you're loading, do not render the options. So no, it's loading. There's no options if it's loading, and we can actually display a hard-coded option if it's loading. So say it's loading, then display right in option, and these options will be loading. So it will kind of display a loading option. Let's see how this looks like. Perfect. There we go. Now this looks a lot better. We have loading, it's disabled, and as soon as the options come through, you will see. Okay, so functional requirements first. They go first. They seem obvious. They're not obvious. I've seen a lot of people failing interviews because they don't pay attention to those. Number two, we need an error state. Right? We're fetching things over HTTP. There might be an error happening, and before I do that, I'm gonna fake an error. Let's fake an error. We go back to the function that I implemented here, which is a mock fetch, right? It's just a fake promise that I'm making, and I'm resolving that in 6,000 seconds. I'm gonna decrease that so we have faster feedback. And what I would say is, you know what, I want this to randomly fail. So how can we do this? Well, we basically can say generate a number with method random, and this will be a random number between 0 and 1, and if that's higher than 0.5, then reject the promise. Do not bother resolving the promise, and reject it with an error has occurred. So pretty basic random error. Let's see if this works. So again, it's very handy for you to know how to modify promises. Even if you're a React developer, you need to know very well JavaScript. Now let's reload this a bunch of times. Did I save that file? Let me see if I save. I'm gonna save it. I'm saying, okay, if method random is higher than 0.5, then reject that, and perfect. And else, then resolve it in a certain time. Okay, so if I refresh this a bunch of times, I would definitely expect this to fail. Let's see if there's any failure. Okay, but my component doesn't really reflect that failure. As we see, it stays in, it doesn't really, it just stays that, and and then it stays as loading. So this is very misleading as a user. Very important. The state of the application should be somehow reflected to the user. So let's add our error state, also part of our functional requirements. And for error, I'm going to simplify this. I'm going to just have its error, but normally we want to know more than just a boolean about our error. So we could say it's error. Actually, I'm going to call this error, and I'm going to set error, and I'm going to start with use state where our error is just false, or it can be a string. I'm going to define the type of this. I'm going to say this could be either a boolean or a string. Now we do have our error, and so let's wrap all this. And why do you pop up? Perfect. So let's wrap all this in a try catch. I'm going to use my editor there. It knows how to deploy this try catch. And oh my god, I'm doing this with a notepad on my Mac, and so it's super annoying, but okie dokie. And so we now cache the error, and we want to set the error to, let's say, plainly the error that we get there. Now this is an error object, so let's see if I can get the error message. And for some reason they're telling me that yes, perfect. So the type, it's unknown. We could make that work with different types, but for now I'll just say an error occurred. Perfect. A very robust way to display an error. Okay, now what do we do if there's an error? Well, instead of actually displaying loading state, we could actually modify this code, but that would lead to very convoluted JSX. So this is the next senior tip. To be more deterministic, we will actually write our alternative path separated. Okay, so I'm not going to modify the JSX here, which would be like, oh, is there an error here, do something else, but I'll actually take it out here and say, you know what, if there's an error, then we're going to do something else. Now I do want to maintain the integrity, the visual integrity of this. So I want this to look as close to what it looked when the happy path happened, and that's why I'll just copy this and say, you know what, I'm still going to display a select. It will be basically disabled. So I'm gonna say this is true, and I will show as an option. I would always show this option over here and say, you know, this is my error message. So I'm going to display our error message. Okay, let me format the code. Perfect. So if there's an error, show pretty much the same. I'm gonna take this off. I don't need all that. Show the same select, but it's now disabled, and display that error. So it's a stable UI, and I will do the same for the loading for the most part. I should do the same for the loading, and you'll see in a second why this is a lot better. I could say if this is loading, okay, then display this and show here loading. Usually this text should come from a translation kind of sort. So, and all of a sudden I do not need this logic anymore. So you see, this will make my JSX a lot simpler, a lot easier to read. So let me format document, and this is another lesson. Okay, we always want to add our conditional logic like this, but we do keep the same structure in order to keep layout integrity and not to have layout switch when any of the scenarios happens. Let's see how this looks like. So we're basically loading. Okie dokie. So something went wrong. Let's check our console. Everything looks okay, but it's definitely not okay. Let me see what's happening here. We say if there's an error, and show that as an error, and show the error. Let me see. We set the error to that. So we should have the error over there, which is disabled. Let me reload this. Maybe, okay, I don't have any visibility on that error happening. So I'm gonna go ahead and also log something to console.error, say an error occurred. And this will help the developers kind of see what's going on. So let's refresh that. The error occurred, but now it kind of compute. Let's see. We do have this kind of work. It works. Let me clean this up. We refresh. Okay, so it looks like we are always displaying this. Let me review this and add an else. So we make sure that if the promise rejects, we do not resolve afterwards. We kind of had both scenarios at the same time. There you go. Now what I'm missing is that loading indicator. So it does load, but all of a sudden it wasn't displaying my loading text because I made a new by mistake, which is that there's no return statement over here. We want to return. There we go. Now that's the behavior we wanted. It's a stable layout. Okay, and if there's an error, we have an error. Not very pretty. We could work with an ellipsis property here to make sure this text doesn't overflow, and we have stability on the x-axis too. Take note of that. Now we do have our layout stability. We finished our functional requirements. The next thing would be to look a bit at the code organization, and finally I will look at non-functional requirements. And you see, as a senior developer, you should be able to talk about this code forever. And this is one of the lessons I want you to take out of this video, is that seniors can drive implementations. They are not passive. They do not need time. They do not need someone to tell them how this has to be built. They have their own standards on how things should be delivered. They can adapt to the situation, but if we have enough time, they could go on and talk about 5 hours about the single dropdown. And you see in a second that we can actually do that. I'm not going to spend 5 hours in this video, but I want you to know that it is possible, that we can go very deep into this. So in terms of code organization, visualization, it's pretty obvious right now that there's two parts to this component. There's one of them that's just kind of painting everything, which is this bottom part, the JSX part, kind of only presenting it. And then there's the logic. And we could split this into a custom hook, and then we have a one-liner. But I like the idea of stateless components. So I like the idea of breaking this apart. And I'm going to apply the solid principle here. Solid, the first one, which is a single responsibility principle. And with solid, what we will do is that we split basically our dropdown into a dropdown wrapper. Let's call it that way. That will handle all this logic. And then we take all this, which is our presenter, and this would be our presenter component, and it has no logic. So I'm going to start here, and I say that this will be my return presenter dropdown. Let's call it that way. And so this will receive all those props. Now let me declare that, and because this is hoisted, I can do it even here. Presenter dropdown, and basically this will receive some props, which we'll see in a second which they are, and it will then finally return, well, basically what we were already returning. So I see there's loading error, there's unchanged and selected value. So let me declare an interface as the presenter dropdown. I do not have compiler to help me out. Oh my god. It usually would be able to really print this out in a second, but this is good practice. It's good to see that we can do things by hand too. This loading would be a boolean, and then we have our options, which are an array of option. And then what else do we have? We do have our unchanged. And for now, I'll choose this very robust unchanged, which is like a function that returns void, but we can type the argument later on. And so this would be of the type presenter dropdown, have our error coming to, which could be string or a null. And then we will have our it's loading coming to, we're going to have our options, and we're going to have our unchanged. Is there any other error here? There is selected value, and I think in our case, selected value, it's actually string. And so we also have that one. Pretty straightforward, right? I take all my presentation layer and I add it here. Now it's just this kind of self-closing, and now we will pass all of them in line. So we make this pass. Also, as you see, this is one of those cases where TypeScript actually helps. It's not getting it away. Sometimes you need to make all those type gimmicks, as I call them, so string or boolean, okay? String or boolean to make TypeScript pass, but it's not the case. We also have our unchanged, and finally, perfect. You see, so this is an event of change event that I need to type out. I mentioned that I didn't type out the input, and finally, you see, I am using perfect. And then we have the selected value. Let me just add it here. Selected value. It's actually selected value. So perfect. Now this is now our component. It looks a lot cleaner, and I could actually split files. I'm gonna do this with the editor. Why is dictionary opening all the time? Anyways, I'm gonna select all this code, and I'm gonna show you a little trick that I do love, which is I take all this and I'm going to refactor, and I'm going to move to a new file. And usually it works, but when I have Loom, the recording software, it usually doesn't. Normally it should move all this to a new file out of the box straight on your own device. Now we do have our solid principle applied. I split this, looks a lot cleaner. I can worry about the logic here. I can worry about anything else here. It's a lot easier to test this now. I can mark everything and write unit test. And it's also a lot easier to test this in isolation because honestly, all the logic is kind of living here. So that was that. We applied solid principles to refactor the code. And now there's the non-functional requirements, which is the last part I want to talk about. And usually in the front end, we will talk about performance as in web performance, not scalability. Web performance is basically how the application performs in the browser of the user. And we will talk about accessibility. Accessibility. Okay. I always misspell this. What's the problem here? Quick fix, accessibility. There you go. Now, these two non-functional requirements, there's another one that it's web security. We'll see in a second that there are some nuances there, but not too much. So let's look at number one, accessibility. When it comes to rendering this, most of the logic, it's in the presenter dropdown, and that's cool because this is the only one that has now to worry about accessibility. The best way to make something accessible is to use semantic tags. Div is not a selected semantic tag. We're not going to be using it. So do not add necessary divs to your components. They do not help. So I'm going to take them out right now. Other than that, all the code here is semantic, which means the accessibility DOM that is being rendered knows exactly what's going on here. I do not need to add ARIA labels. And remember, ARIA attributes, which is what we need to make non-semantic HTML accessible, are an anti-pattern because they need to be maintained. So you want to avoid them as much as possible. Try at the very best to write semantic code. This is semantic HTML, so we can move on with accessibility for now. But we'll see that it's a case where this becomes important more later on. Let's talk about web security. Now, the only problem that can happen here is because we use this label, and this comes here, they could send, like an attacker could possibly send HTML or JavaScript here, and we might somehow end up rendering that. It's a variable, but that's the only thing. So you might have to make some checks on the sanity of this option list. So whenever we fetch the option list, we could check that there's no HTML tags or JavaScript like script tags inside that text, and maybe we could check a max length. Other than that, but assuming this comes from our server, we could probably safely move on. But this is what I would mention on web security sanitization, because we render content from server. And so there's different attacks that an attacker could basically perform with that. But for now, let's assume that we don't need to sanitize these values because they are from our web server. They are not user persisted. If there's drop-down, that drop-down would come from something a user would add. Like imagine it's a drop-down or user names. A user might add in their name like an HTML script that could end up running, basically doing an XSS attack on the on our user's website without them knowing. Finally, performance, and this would be React optimization. So basically here, I would look at re-renders and renders. We could maybe run a use callback over here, but it's not very useful. And then whenever we return this, like this presenter drop-down, if it would have some props, the best optimization is to run this, to wrap this in memo. So basically, instead of returning the drop-down as it is, I will take it and then use memo on it. Again, this doesn't receive props, but here we do receive a lot of props. So this is where the presenter drop-down could actually be optimized. So I'm going to take all of it, I'm going to cut it out, and use memo and pass it as an argument to memo. And what memo does is that it will check the props. So it will make sure that this only re-renders when the props actually change. So that's the first optimization. When it comes to performance, I would check for the keys. They are unique. And that's pretty much it. There's no need right now to do anything else in the performance side. I do not see any opportunity for use callback or use memo. There's no expensive values here, but do keep this in mind. It's still two hooks. So that was optimization. We look at accessibility. And now finally, a very advanced kind of legendary level, let's say legendary React level, would be, can we build this without the select / option? And I would estimate this takes around 30 minutes. So I'm not going to go into it, but I'll give you a rough idea of it. But basically, you want to do this when you want to have your own styles. So if having our own styles in dropdown, it's a requirement, styles, then you need either a library that gives you a dropdown, or you need to build your own dropdown without this select. And that's when the challenge comes in, because all of a sudden there's a lot of behaviors here that we would need state for, and we'll also need to style it, and we'll also need to make it accessible, because it will no longer be semantic HTML. Okay, there's one mistake. So probably in this option, I could add an ARIA error kind of, there's an ARIA error message. Yeah, and then we put the error here, and probably now it will tell me by the all option. Perfect. So probably I'll have to replace this with a span, something along those lines, if I want to make this to be like an error. And all of a sudden I will get the same, because I cannot put a span inside the select. So I'm going to make this a div, and I would need to style them if I were to be 100% accessible. So why is this? So we have a div and then span, the property. Okay, so basically error message. If it's an error, it's basically telling me that this can be string or undefined. So error shouldn't be. I can only use error because error it's of type string. If error, let's try an error dot linked, so it's greater than 0. No, then I could say if the type of error that's equal to string. Okay, kind of work around. So, but right now this would be more accessible. So as you saw, we can overlook that, and it's the same for loading. I should have to replace that, and then I need to style these things, and then I need to point that this is a container. Now going back to rendering this as a non-native element, that would take a lot of work. But what we will need to do is to actually render this as a button, and then render these options as a list, and then style them accordingly. So I'm gonna write it here. This would be a button. This would be a list element, and I would need state. I'll need state for wherever you click on the button. We want to show the option list. So all of a sudden, this stateless component wouldn't be stateless anymore. It will need an its open state at the very least. And now, if we look at it, let's refresh. Okay, it's loading now. You see, when I click, that's the first state change that happens. So I need state for that. And when I move, I'm also selecting it, right? So I'm selecting a different one, and that would be the second list, or we can call this highlighted option. So it will be my second state variable. Okay, so I'm gonna have an its open state, and then I'm gonna have a highlight element state. Okay, these two are the ones necessary to replicate this behavior. And what am I gonna have as state transitions? Well, whenever I click, I change, right? Whenever I click here and click outside, I need to close that. So I either click on here and I close, it's open becomes closed, or I click outside. So I'm gonna need a ref. That's another thing I'm going to need. I'm gonna need a ref to track clicks outside. So all of a sudden, this will become a very complex component. I will not do it in this section. I might make a super advanced kind of legendary example on how to refactor this. But the main idea I want you to take out of this is that whenever you are refactoring, a senior level candidate could probably go in and go on for 3 hours, right? They will never run out of things to say, because one of the things we didn't talk about, it's also testing. So you could go ahead and try to test this component, add the proper IDs, styling it. You could spend around a week building a real reusable dropdown. And just to mention a list of topics that I did not touch upon, but you might look into it, you might want to look into the shadow DOM. So this would be an isolated CSS namespace only for this component. So if this is a reusable component people use, we make sure that our CSS classes do not clash with their CSS classes. The other thing would be looking into virtualized lists. They will allow you to, if you have thousands of options when we render, only render the ones that are visible, and as the user scrolls, show or hide other ones, so we do not have against memory leaks because we render too many components. So these are two super advanced, hyper advanced topics you could apply. I'm not gonna do it in this video because again that would take me around 45 minutes, but I can do a longer session when we go in depth. So this is pretty much what we've done. Let's see our div. Basically, as you see, we added the loading and our state. We make sure we have the appropriate state transitions. We apply separation of concerns and split this into two components, and we memorize the presenter one, which makes it a lot better, like a performance wise. And the other thing we talked about were more advanced accessibility and building this without the native elements. So this is how a senior will look at the code. And whenever you have an interview where you need to refactor code or you need to talk about code, feel free to take this, first of all, functional requirements and then non-functional requirements principle, and make sure you never run out of things to say. Senior developers, senior candidates are very proactive. They know the best practices and they can move the needle forward. That's what's expected of them. I'll see you in the next one.